Hey Panthers! This is the video for Lesson 3 in Expressions and Equations topic in your math book. If you didn't watch Lessons 1 and 2, the link is in the description. In Lesson 1, if you remember, we talked about writing expressions. In Lesson 2, we talked about equivalent expressions. So this week, in our third and final lesson, we'll be talking about solving expressions and equations with variables. So make sure you've got your remote learning book and a pen or pencil handy as we follow along through this guided lesson.
So we're still in topic 2, expressions and equations, and we're going to be finishing off this topic with a lesson in solving equations. This is in your first packet on page 120. But if you look on the blue left side of the paper, it says 184, and I've snipped it off of mine. But right here in blue, it says 184, but the actual physical number that's going to be right at the bottom is 120. And remembering, we're still in packet 1 for math. This will be the last lesson in our second topic. So let's get right into our third and final lesson in solving equations. Reminder, if you haven't watched the first video the first two videos for lessons 1 and 2, you can stop this video now and go ahead. And in the link below in the description box will be the links for the other 2 videos. So make sure you go back and complete those so you can have a little bit of foundational knowledge before we get into the third and final expressions and equations video. So let's dive right in to solving equations. In the picture below, we see a balance. And on this balance, we have 10 blocks in one bag with an unknown number of blocks. The pans are even, so they have the same amount on both sides. And we're trying to figure out how many blocks are in this bag to make sure that it's even. So the first thing we're going to do is figuring out, what does this X represent that's on the bag? And so the X is going to, the bag that has the X on it is going to represent the unknown number of blocks. So the number of blocks that are in this bag is being represented by that variable X. So a reminder that a variable is a letter. So now it's asking us how many blocks are in the right side pan. So looking over here, and we're counting these blocks, we've got 1, 2, 3, 4, 5, 6, 7. There are 8 blocks on the right side. And now it's asking us to write an expression for the number of blocks on the left side pan. So I know that I have 2 blocks, so that's a constant number, or just a whole number by itself, 2. But I also have this variable X, which is an unknown number of blocks. So if I were to create an expression for the total number of blocks that's on the left side pan, it would have to be X plus 2. Because I know that the total amount is going to be this 2 plus whatever number of blocks are in this bag. So on the right side, I've got 8, and on the left side, I've got X plus 2. Letter D is asking us, what will you need to do to get the bag by itself on the left side? So in order to get the bag by itself, we have to get rid of those 2 blocks that are right here. So to get rid of those, we're going to take away those 2 blocks from the left side. And when we take those 2 blocks away from the left side, do you notice how the left side pan is going to go down, and it's going to go up, meaning that the left side pan is now lighter than the right side pan. So there's something that we have been talking about that we literally scream at least once a day in my class, and that is, whatever you do to one side, you must do to the other. So if we took away 2 blocks on our left pan, we in turn, to keep the pans even, we have to take away 2 blocks from the right side too. So in order to keep those pans hanging evenly, you have to take 2 blocks from the right side as well. And then explain how you could find the number of blocks in the bag. So when you take 2 blocks from the left side to get the bag all by itself, and then you have to take 2 blocks from the right side to keep the scale even. So the number of blocks that are going to be remaining on the right side, which is 6, because 8 minus 2 is 6, is going to equal the number of blocks in the bag, which is x. So in this case, x equals 6. And this page right here is a great, awesome note page. So remembering that if you get stuck on any assignment in expressions or solving expressions, to come back to this page right here that I have highlighted in yellow. I'm going to go through it very quickly. It says to find the number of blocks in the bag, you had to do 2 things. You had to get the bag with the unknown number of blocks by itself on one side of the balance. You did this by taking away 2 blocks from the pan with the bag. Then your second step that you had to do was to keep the pans hanging evenly. You did this by also taking away 2 blocks from the other pan. The pan balance, blocks, and bag represent this same equation, x plus 2 equals 8. To solve this equation, you have to do 2 things, which you're going to notice are going to sound a little familiar. You have to get the variable x all by itself on one side of the equal sign. So another way that we say that, and the verbiage that we're going to be using when talking about expressions, is called isolating the variable. So whenever you see isolate the variable, that means to get the letter all by itself. So the second step you're going to have to do, so keep that in mind, isolating the variable. The second step you have to do is to keep the 2 expressions equivalent to each other. You got to keep it balanced, and you're going to hear that verbiage a lot too. Whenever they're saying keep the equation balanced, it's meaning whatever you do to one side of your equal sign, you must do to the other side to keep your balance. So this is going to be a great example problem right here. It says, how do you isolate the variable x in the equation x plus 2 equals 8? And here's another new vocab, using inverse operations. So an inverse is going to be an operation that undoes the other one, or the opposite operation. So addition and subtraction are inverse operations. They're opposite of each other. And multiplication and division are inverse operations. So they're opposite of each other. So when we look at this expression, x plus 2 equals 8, we can see that 2 is being added to x. So in order to isolate the variable, or to get the x all by itself, we have to subtract 2. So we're going to do the opposite of addition, which is subtraction, and then however much we need to get rid of to get the x all by itself. So in this case, we had to subtract 2. But we always have to remember to keep our equation balanced, meaning whatever we do to the one side of the equal sign, you must do to the opposite. So we have to subtract 2 from the other side of our equal sign as well. So we have to do 8 minus 2. So I need you to think about this as 2 minus 2 is 0. So we got rid of the number. We got the variable all by itself, which is what we were looking for. But 8 minus 2 is 6. So in the end, x equals 6. We're going to be doing a lot of example problems. We'll be doing some addition, some subtraction, and multiplication and division. But this right here says write an equation for which subtracting 5 from an expression would isolate the variable. So we have to think in our head, if they want us to subtract 5 to isolate the variable, the opposite of subtraction is going to be addition. So I know that in my head I'm thinking, okay, well I need to have an x plus 5 as my problem. So an equation, an example of an expression could be x plus 5 equals 10. And in this case to solve, I would subtract 5 from both sides of my equal sign in order to isolate the variable. So that absolutely answers that number 1. Reminder, this is highlighted for a reason. It's a great resource page to come back and check out if you get stuck. So let's move right in to solving addition and subtraction equations. This says, suppose you have a bag with an unknown number of blocks, and you take 3 blocks out of the bag. Then you put the bag in one pan of a pan balance. It then takes 7 blocks in the other pan to make the pans hang even. How many blocks were in the bag before you took that 3 out? So they always like us to picture, right? And here's a great picture because we know our bag had X amount of blocks. And then we took 3 out. Whatever X was, which is an unknown number, we took 3 out from there. And that's what this bag shows, which is X minus 3, because from our sentence in our problem. Then we know that it takes 1, 2, 3, 4, 5, 6, 7 blocks to balance this equation. It says the label on the bag means that the bag has 3 less than some number of blocks in it, or X number of blocks. So this is just a great way to picture it. And now here's the solving it. So it showed us the number of blocks on the left side, which is X minus 3, and the number of the blocks on the right side of plan, which is 7. I need you to think of the middle part of our balance as the equal sign. So we can think of this as an expression, or an equation, X minus 3 equals 7. And that's what they wrote down here at the bottom. So we're going to be solving for the equation X minus 3 equals 7. So reminder, if you want to be looking at your picture it and your solve it on the other side as we're answering the connected questions on this side, just make sure you're checking out that other page because I can't show you both pages at the same time. So let's look at the solve it on the previous page. If you solve the equation X minus 3 equals 7, what information are we going to have? So if we actually solve for X, what information does that give us? What is X equal to? So I'm looking back here, and the number of the blocks that's in this bag minus 3 is going to be my X. So what information that I will accumulate is I'll know the number of blocks in the bag before we took out 3. So that X, that variable, stands for the number of blocks in the bag before we took out 3. So now we have to just simply, when we're trying to solve this equation, we have to think about what operation do we see in the problem. So the operation in the expression X minus 3, the operation is subtraction. It's not, we see a subtraction sign, so we know that it's subtraction. So now number 4 is asking us, what is the inverse of this operation? Now remember from that notes page that the inverse is going to be the opposite of the operation. So the opposite of subtraction is going to be addition. And so in order for us to solve this equation, we know that we're going to have to use addition now because it's the opposite of the operation that's being used. So how can we isolate the variable in X minus 3 equals 7? Well, remembering that isolating the variable means to get the letter all by itself. So in this case, we have X minus 3. If I wanted to get X all by itself, I have to do the opposite of subtraction, which is addition, and I have to add this amount right here. So I need to add 3. To isolate the variable, I need to add 3 to X. And if I add 3 to X on my one side, you must keep your equation balanced. So in order to keep our equation balanced, whatever I do to one side, I must do to the other side of my equal sign. So if I'm going to add 3 on one side, I must add 3 to the other side. So I need to add 3 to 7 to keep my equation balanced. And if you notice, I wrote in all capital letters, whatever you do to one side, you do to the other. That is the key when solving equations. So now let's look at this example. We're going to actually see the addition happening here. So we see our original problem, x minus 3 equals 7. So the first step we have to do here is isolate the variable, which remembering means to get it all by itself. So we need to do the opposite of subtraction, which is addition. So we add 3. And when we add 3 to one side, we have to add 3 to the other side. So when we do negative 3 plus 3, we get 0. And then on this side, if we do 7 plus 3, we get 10. So now we've got this equation, x plus 0 equals 10. Well, when we have something that says plus 0, we can just get rid of that plus 0 because it's not changing the x in any way. So now we just have x equals, and my 10 is going to stay the same on the other side. So x equals 10. So if it asks me how many blocks were in the bag before I took 3 out, oh, there were 10 blocks in that bag before I took 3 out. So now we're going to do this try it. I'm going to go to the dry erase board here for numbers 9 and 10. And this says solve for x plus 5 equals 15. And so I have the operation that is addition. So in my head, I need to think of the inverse or the opposite. So I'm going to subtract 5 from the x. And reminder, whatever I do to one side, I have to do to the other. So I'm going to subtract 5 on the other side of my equal sign of my 15. So when I take 5 minus 5, those two are going to cancel out and leave me with just my variable x. So I've done a great job of isolating that variable. And then if I do 15 minus 5, 5 minus 5 is 0, 1 minus 0 is 1, I get a final answer of x equals 10. So now let's look at number 10, where we have x minus 9 equals 8. So this one's the opposite of number 9. My operation that they're using in my equation is subtraction. So I have to think of what's the opposite or the inverse of subtraction. Well, that's addition. And I need, in order to cancel out my 9, I need to add 9 to x. Whatever I do to one side, I have to do to the other. So I need to add 9 to 8 as well. When I do negative 9 plus 9, those are going to cancel out and leave me with just the variable x. And then 8 plus 9 is 17. So I can see that x equals 17. So now we're going to move on to the multiplication equations. And we have to remember that if the opposite of an addition problem is subtraction, and the opposite of subtraction is addition, then we also have to think of the inverse of multiplication is division. So this is a great time during these weeks off. If you are not 100% fluent in your multiplication and division facts, that's what you really should be working on during this time, just to make sure that you can seamlessly answer these questions without fumbling over the operations of just doing the division part. So this says, Delia puts 2 bags of blocks in the left side pan of a balance. So here's our 2 bags of blocks. Each bag has the same number of blocks. So notice how they're both labeled X because they're the same. After she adds 10 blocks to the right side pan, it hangs evenly. How many blocks are in one bag? So here's our picture where we can see our 2 bags that have an equal number of blocks in it, and we have our 10 blocks on this side. So the 2 bags in total are going to equal 10. But they're not just asking us for how many is in both of those bags, but how many is in one bag. So here's how we can write an expression after we've pictured it this way. I can see that I have 1x and I have 2x. So I have 2x on one side of my equation, and reminder, thinking of this middle section as an equal sign. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. So I have 2x equals 10. So the number of the blocks on the left side, 2x, equals the number of blocks on the right side, which is 10. So as we answer the connect-it questions, make sure that you're looking back to that previous page. It says, what do you need to do to find the numbers of blocks in one bag? So in order for us to find, the number of blocks in one bag, we're going to have to solve that equation 2x equals 10 that we came up with in the second part. So in order for us to solve that, we know it's a multiplication problem. And it tells us that we're combining two equal groups, because that's really the definition of multiplication. You're combining equal groups of x blocks each. So the opposite of combining two equal groups together is going to be splitting the blocks into two equal groups. And when you're splitting into equal groups, that should be ringing a bell in your head. That is the definition of division. So the operation that's the inverse of multiplication, reminder that the inverse is the opposite, is going to be division. So in order for us to solve an expression that has a multiplication problem, where there is a variable multiplying a number, we're going to have to divide. So how can we isolate the variable in 2x equals 10? Remembering isolating the variable is to get it all by itself. So if 2 is multiplying x, in order to get it all by itself, we're going to have to divide x by 2. And then remember, whatever you do to one side, you have to do to the other. That's balancing the equation. So if we divided x by 2, then we're going to have to go ahead and do the same thing on the opposite side with the 10 and divide that 10 by 2 as well in order to keep that equation balanced. So looking at number 16, this is looking at the problem as it would be written on a board. And we see 2x equals 10. And then first thing we have to do is isolate the variable, which is like what we wrote down in step 14. We need to divide x by 2. So we're going to divide x by 2, and then whatever we do to one side of our equation, we have to balance and make sure we do it on the other side of the equation. So if I look here, this 2 divided by 2 is going to cancel each other out and leave me with just an x. And then I've got 10 divided by 2, which equals 5. So how many blocks are in one bag? Oh, there are 5 bags, or I'm sorry, there are 5 blocks in each bag. And it asks us, how could we check our solution? So when you come up with this answer of x equals in a number, x equals 5, the best way that you can always go back and check your answer is by plugging this number in to your original problem. So in this case, we're going to substitute 5 into the original equation. And if it makes a true statement, then we know we got the right answer. So if you look at our work, when I plugged it back in, I've got 2x equals 10, and I plugged in 5 for x. So I have 2 times 5 equals 10, and I know that 2 times 5 is 10, so I get this statement, 10 equals 10. That's true. They're the same number, so I know that I got the correct answer of x equals 5. So now for number 19, we're going to go to the dry erase board, and we're looking at this number, 7x equals 21. And I know that I am multiplying, because whenever I see a number next to a variable, I know that they're multiplying. So I'm multiplying 7 times x. In order for me to isolate the variable of a multiplication problem, I'm going to divide x by 7. And whatever I do to one side, I have to do to the other. So when I see 7 divided by 7, those cancel out and leave me with the variable x. And now I've got 21 divided by 7, and I know that that is 3. So the solution to 7x equals 21 is x equals 3. And if I wanted to check that just to be sure that I got the correct answer, I would plug that 3 in for x, and I would do 7 times 3 is 21, so 21 equals 21. That's the same answer. That's a true statement. So I got the correct answer of x equals 3. So now we're going to be moving on to solving equations for real world situations. We're going to be using some of these tape diagrams that are helpful. So if you are needing these and using these to show your work, when you get to your independent work, make sure you take a picture of them and send it my way. This says, Rita sells 6 tickets for a school fundraiser. The total price of the 6 tickets is $84. What is the price of 1 ticket? So here's a bar model that we see 1, 2, 3, 4, 5, 6 boxes all having T. And I can see up here that the total amount is $84. It says the top bar represents $84, which is the total price of 6 tickets. The bottom bar represents 6T, which is the total price of 6 tickets Rita sells. So we can see that each of these bars and each of these blocks are all equal to T. So these are all the same. And when we're trying to solve this and writing this into an expression, this is how we can think of it. Let the price of each ticket, we're going to keep ours as X because I always like just working with X. It says writing a sentence. We can think that the number of tickets times the price per ticket equals the total amount of tickets. So we know X is the amount of price for each ticket. That's what we're trying to solve for. And we have 6 tickets and their total is 84. So when we write that out as 6 times T or X equals 84. So as we move on to the connected page, making sure you're checking back to that previous page. So it says, looking at the solve it on the previous page, what is the operation in the equation 6t equals 84? So whenever we see a number next to a variable, we know that that's being multiplied. So that's multiplication. And the inverse of multiplication, or the opposite of multiplication, is division. So when we're looking at this problem, 6t equals 84, the first step for us in solving any equation is trying to isolate the variable, or trying to get the variable all by itself. So in this case, I've got 6 multiplying t, and to get that all by itself, I'm going to have to divide t by 6. And then in order to keep my equation balanced, which means whatever I do to one side, I've got to do to the other side. So then I've got to also, if I divide t by 6, I'm going to have to divide my other side of the equal side, 84, by 6. And looking at it this way is a little bit easier, especially for me. So if I see 6t equals 84, your first step, isolating the variable. So I need to divide 6t divided by 6. And then whatever I do to one side, I have to do to the other. So I've got 84 divided by 6 as well. 6 divided by 6 is going to cancel each other out and leave us with just t. And then 84 divided by 6 gives us a final answer of 14. So the price of 1 ticket is going to be $14. Remember, you're always doing the opposite of the operation. So they were multiplying, I just divided both sides. And it says, explains how you know what step to take to solve an equation. This is the best explanation, and this is that I could come up with. And I'm going to star it. It's pretty important. If you get stuck or lost to come back, you can just read through that and it might trigger something in your mind. It says, look at the operation used in the equation. Then use the inverse or opposite of that operation to isolate the variable, which means get it all by itself. Remember to do the same thing to the other side to balance the equation. Whatever you do to one side, make sure you do it to the other. So now we're going to get into our guided examples, our guided practice. I'm going to be doing these up on the dry erase board. Here's your example problem about Amanda. If you get stuck in your independent practice, this is a great spot to come back to and double check. So looking at number 28, it says Ray and Hunter sell newspapers after school. Ray earns $11 more than Hunter. If Ray earns $25, how much money does Hunter earn? So when I'm looking and I'm trying to set up my expression first, and it says we're trying to, first I want to set up my expression. So I need to figure out what is my x, what is my variable, what information am I trying to find out? In this case, it's asking me how much money does Hunter earn? So my x is going to be Hunter's earnings. And when I see that Hunter, I don't know how much Hunter made, but I know that Ray earns $11 more than Hunter. So whatever Hunter made, X, I can add $11 to that, and that's going to be what Ray makes. And Ray made $25. So I can come up with this expression, X plus 11 equals 25, because X is going to be, what does Hunter make? And then we add the 11 extra dollars that the problem told us, and we know that that's 25. So in order for us to solve this, my operation is addition. So in order to isolate my variable, I'm going to do the opposite, which is subtract 11 from this side. And whatever I do to one side, I'm going to do to the other side. So 11 minus 11 is going to cancel each other out and leave us with the variable x. 25 minus 11, 5 minus 1 is 4, and 2 minus 1 is 1. So my final answer is that Hunter is going to earn $14. So now looking at number 29, we have Nina has 2 cups of flour. However, this is only 1/4 of the amount of flour that she needs for this bread recipe. How many cups of flour does the recipe call for? So my first thing I need to determine is, what is my x value? What am I trying to solve for? In this case, I am trying to determine the total amount of flour for the recipe. So I know that I don't have that information, so I have x. I don't know what the total amount is, but I do know that Nina has put 1/4 of the total amount into her recipe so far. So 1/4 of the total amount of flour is going to be 2. So if I'm using that, I can come up with an expression that says x, which is the total amount of flour, times 1/4, because 1/4 of my total amount of flour is going to be the 2 cups that she's already put in. So I have x times 1/4, or 1/4 x, equals 2. So in order to solve for this is showing me a division problem. I have 1 divided by 4, and the opposite of division is multiplication. So I'm going to multiply x times 4. And whatever I do to one side, I'm going to do to the other. So I'm going to multiply 2 times 4 as well. My 4 is going to cancel out my 1/4, leaving me with just x on the left side. And on my right side, 2 times 4 is 8. So I know that the total amount of flour the recipe calls for is going to be 8 cups. Now looking at number 30, this one is a multiple choice. It says Tara and Julia run a race. Julia takes 42 seconds to run the race. She is 7 seconds faster than Tara. How many seconds does Tara take? A, 6 seconds, B, 35 seconds, C, 49 seconds, or D, 294 seconds. So looking up at the board, the first thing I need to come up with is, what is my x value? What am I trying to come up with? What is the thing I don't know? In this case, it's going to be Tara's time. So my x value is going to be how long it took Tara to run the race. I know that Tara is 7 seconds faster than Julia. Wait, Julia is 7 seconds faster than Tara, excuse me. So if somebody was faster than me, they ran it quicker. So I know that Tara's time is going to be x, and then I'm going to subtract 7. So whatever Tara's time is, Julia ran it 7 seconds faster. So I can do x minus 7 equals 42 because I know that my x value is Tara's time and Julia ran it 7 seconds faster. So she ran it 7 seconds slower than Tara. So 7 seconds, so it'd be Tara's number minus 7 would give me Julia's number. So I've got x minus 7 equals 49. So I have a subtraction problem. I'm going to do the opposite, which is going to be add 7 to x, and then I'm also going to make sure I do that to my other side of my equal sign. Negative 7 plus 7 will cancel out and leave me with just x on my left side. 49 plus 7 will give me 42 plus 7 will give me 49, which will give us a correct answer of C. Tara will take 49 seconds to finish the race. The second part of this says Nolan chose B as the correct answer. How did he get that answer? So B was 35. So I can kind of see that instead of adding 7 seconds to Julia's time, that Nolan subtracted it and made her faster. So he solved the equation x plus 7 equals 42. So he solved it as that Tara was faster than Julia. And whenever we're kind of dealing with races and dealing with faster and slower, sometimes it does get really confusing. So this our study buddy over here, kind of before you even started thinking about math, it said which girl takes the least amount of time to finish the race. So you should have looked at that and said, Tara and Julia ran a race. Julia takes 42 seconds. She is 7 seconds faster. So not even thinking about the numbers, I know that Julia was faster than Tara. So if I got an answer that was smaller than 42 that Julia ran, like Nolan did, then I should have went back and figured out, I know that Tara was slower than Julia, so she should not have had a smaller number. So your independent practice is going to be a couple of pages today. You've got a couple multiple choice reminder if you're showing your work if you're doing this online and you need to show your extra, or you need a separate piece of paper to show your work, you still need to be emailing that or Snapchatting it to me. You may complete it interactively and turn it in on Google Classroom. However, I do want to see your work. And you may also be completing this handwritten in your remote learning book and either emailing it or Snapchatting it to me. So this was your last and final lesson on expressions and equations. Make sure you get that Kahoot done, and let's see how you all did this week.